So again, in case you are unaware, May the 4th be with you.
May the fourth be with you
I would have
too.
wanted a Star Wars shirt, but I wasn't.
So today is Star Wars Day for those of you who are unaware. So your homework is still 15-2. It was already posted, so some of you already did it. So if you already did it, write it down, cross it out. You do not write down no homework because then that would be inaccurate. Because you never know when that last quiz bowl for the MI Olympics might just ask you plan book questions. You don't know.
Math
That's
problem?
the thing. I don't know.
I know you don't.
So,
Are we working together for the quiz bowl?
Yeah, your whole team participates.
Thank God.
Whole team participates. So, do you guys have this on your paper? You do not. So that's fine. So Data Girl plans her research. So we're checking back in with Data Girl. We chose her research because she had every single Tuesday, right? So provide a possible response for each question. The airline is asking to answer the following questions as part of her plan. So she's trying to present this data. What is the who that we're talking about?
People.
People, but more specifically, how could we talk about these people? How could we give them a title?
People going to Puerto
Ooh, who said it? Passengers. So we could say that these people are passengers because we don't care about the people on the flight crew, like the the pilot and the stewardesses and all those people. They're not going to be part of the data. They always fly. That's their job. What about the what? Yeah, probably though we'd say like flying to Puerto Rico so that we're a little bit more expensive. Or sorry, not a little bit more expensive. A little bit more explicit, a little bit more clear. So where, well they're on a plane together. When? Tuesdays. Why?
Because they want to go.
They have a common goal, right? They're trying to get to a destination. So when we talk about data, we need to be able to answer these questions. Who, what, where, when, why. Sometimes how gets added in there. But who, what, where, when, why are those really important questions. Now you guys talk about those in language arts because those are important when you're writing. But we need to talk about those when we're presenting data. Because if you're going to present data, you need to have a background story for it. So when we're dealing with one population. So how many students in my school play a sport? I have the population here is what? What population are we dealing with?
All the
Students. Now that's what I'm asking is who plays sports.
students.
So I'm talking about students in my school. So when I have a population, you have a question about a trait or a whole group. Now when we have multiple populations, where'd the extra notes go? Because I need a copy of reference. Oh, all right, they just all back there, that's fine. So what's the situation where you think then we break the population in two? Can anyone give an example? Maybe here at Phoenix? Isaiah?
Girls who play sports and boys.
Yeah, you could look at girls versus boys. We could look at 7th versus 8th grade. We could look at us versus McCord, compare two different schools together. Or we could just say, split yourselves up into whether you play sports or whether you don't play sports. We know that this split pretty much happens at extensions. Our friends, our classmates that go play sports, they get on the shuttle bus, they go and they play sports. Then we don't. So are students who play a sport generally taller than students who don't play sports? So now we have a question that compares the populations against each other. So what do you think would happen if I did two populations asking that taller question with 7th grade versus 8th grade? Who do you think would normally generally be taller? 8th grade, right? They're older. They've matured longer. What do you think here? If we have people that play sports and people that don't play sports, what would be your expectation for these results? If we're asking for who is taller. Why? Dude, I mean, it's a good guess. Why would those people be taller? Yeah?
They have more advantage.
Yeah, maybe.
With basketball, they are taller, so they can reach the basket.
Yeah, with basketball, being taller makes you better. With baseball, it increases your swing. With track, it makes you run faster because your legs are longer. With football, I mean, there's advantages to height. So probably our athletes will be taller. We don't know that yet, but we could make that guess or that estimation. I'll hold up. Got to go back and capture this. And then when we have multiple populations, we can have more than one, more than two, more than three. We can have as many as we divide it out. So if Phoenix, in my dream, would have 6th grade also, then you can break your population to grade 6, grade 7, grade 8. And we could ask a question like how many students in each grade, because there's statements in each of these that split my population. So since we have in each grade, that divides out my population. So every group, every population that you see can be broken up into multiple populations based off shared characteristics. They have to all have something in common. So a teacher give a test to each of her 3 math classes. To answer each question, should the teacher consider the classes as 3 populations, so separated out, or as 1 population together? So we will use a random draw for this one. If we're looking for what was the highest score overall, looking for the highest score overall, should we look at 1 population, or should we break it up into 3 populations? Of course he's absent. Layla, what do you think?
I think we should. I think we should use 3 populations
Why is that?
so that we can get like a bigger representation.
I don't know if I'm asking this question well. So what I'm asking is when the teacher asks the question, what was the highest score overall? She's determining, like let's say she has 3 different periods of the same math class. Let's say I teach 3 periods of math 7. I teach 2, but let's say I teach a third. So if I was wondering what is the highest score overall in my math 7 classes, should I look at each class individually, or should I look at all the scores together as 1 population? So that's what we're trying to ask.
All the scores together as 1 population.
Yeah, because if I want the highest score overall, that all right there, that's your big keyword. We would look at everyone as 1 population together because we want overall. So underline or highlight that overall word. So then, Abby's in orchestra. Bela. What about if I want to know which is the top scoring class? Would I keep them all together or would I break them apart? Yeah, because if I need which class is the top scoring, I would need to break them apart by classes. So I would need to look at all 3 populations there. What is the mean score for each class, Eli? What do you think, 1 population or break it apart?
1 population. Because you can compare. Oh, each. 3 populations.
Yeah, because we want to look at each class, I need to look at the 3 populations separated from each other to get those scores from each class. Orchestra. Crystal, what about who is the top scoring student in each class? Break them apart. What's the key word there that tells you? Yeah, again, we see this each class. So I know that I need to look at these as 3 different populations. Eminal, what is the mean score of all students? Should I look at them together or broken apart?
1.
Yeah, 1 population here. And what's your keywords there that indicate that? All students. And Cassidy, how does the range of scores compare among classes? So that would be like asking, like which class had a tight range where their scores close together, or which class had a big range, like because that might mean that I didn't teach it well, and some people understood it on their own, some people didn't get it, or you had a small range that meant everybody's results are close. So would you look at them all together or broken apart? Broken apart, right? Because I want to compare the classes. The only way to compare the classes to each other is to break them into 3 populations. Any questions on how we make that decision of whether I use 1 population together or broken apart populations? The big thing you need to look at is, am I making comparisons? Am I looking to compare one class to the other? I meant to clear. Come on. There we go. All right, so try this on your own. School nurse is testing the eyesight of all students in grades 6, 7, and 8. So imagine that we have 3 grades here. To answer each question, should the nurse consider the grades as 3 populations or all together as 1? Try this on your own. You can move on to the next got it if you get this one done real quickly. You may confer with those people close to you if you would like. Go ahead and move on to the next got it. Just take a couple minutes and really think these through and discuss with the people close to you. Get some good final answers. If you guys can't make a decision, stick up a hand and I'll come over and join the conversation. You look very classy. Well that makes sense. But like it's the jean jacket with like the dress, it just I don't know, it looks like a cool style. You look like you belong in like New York or somewhere.
Thank you.
I don't know what it is about a jean jacket. They never got a style. They've been in style since like the 80s. Everything cycles, styles and all that. More people in Maine or Hawaii. So, could you look at Maine and Hawaii together to get that answer, or would you have to look at them as separate populations? Well, if we're comparing Maine to Hawaii, how many populations are we comparing? 2. I'm trying to get some space on my desk for this document camera. It needs a place to live.
Should you like redo your desk?
Well, I have summer school here too, so as soon as the school year ends, we just roll right into summer school. It's okay. I get like a week off, but we have a couple professional developments. We have this thing called Worthington U, or it's really Worth U. That's like I don't want to say training because it's not training, but it's like conferences that we get together and do. So that's Monday, Tuesday of that first week of summer. Isaiah, if I'm going to look at how many students have perfect vision in the school, would I be looking at one population or would I be looking at broken up? One, because we're talking, what's the key word there? In the school. I don't want to separate them by grade level because I want to look at them together in the school. What is the mean eyesight score for each grade? Brennan.
3 populations.
What tells you 3 populations there?
Each.
Yeah, in the school over here versus each grade. Each grade tells me I'm going to break them up into 3 populations. And Oriana, do students' eyesight scores change more between 6th and 7th grade or between 7th and 8th grade?
3 populations.
Yeah, I would ask you about keywords, but it's pretty much the whole thing because it's 6th to 7th, you'd need that comparison, and 7th to 8th, you'd need that comparison. You gotta have 3 populations. Any questions on these? All right, now the other got it that you guys moved on and did on your own. So, says, why can one population in a study be considered more than one population in another study? This is not on your paper well, it is on your paper, but I didn't really leave you space to answer it. So, why? So when we talk about the school, why is it that I can look at the school as one population And I can look at it as 2, or I could look at it as 3, or I could look at it as 4, or like I can keep breaking it up. Eli, you had your hand up.
Yeah.
Why is that?
Because it depends what you're looking for.
Yeah. And more, so I'm going to change how you said that just slightly. Like what you said is right, but really it depends what we're asking. Everything is determined based on how the question is phrased. So we are, I'm still trying to find class time. Sorry, my socks are sagging. It's very annoying. We are still going to collect that Phoenix data. So one of the things that you have to think about as you formulate that question that you're going to be asking is, am I looking at everybody together? Am I looking at boys versus girls? Am I looking at 7th versus 8? Are you separating the population, or are you keeping everybody together, asking one general question to the whole population? Because that's really important to how you present your data. Were you looking at one to joined population or separate populations? So we are analyzing U.S. Census data. What's the census?
Here in Maine.
With my family in Philadelphia.
Came to Chicago.
Third generation in Los Angeles.
Trying to mimic, like,
Grew up here in Hawaii.
they're not very good. In Maine, there's a pretty they have pretty interesting accents up there.
Yeah.
One of the funniest things is when they say car keys, because a lot of AR ends end up sounding like AH. So they'll be like cockies, like where'd the cockies go? So it ends up sounding like khakis, like so. Because my sister and brother-in-law lived up there for like 2.5 years, and they've got really interesting commercials. Like if you ever want to like listen to their accent, just YouTube search like Maine commercials, MAINE commercials. But so here we go. Research is analyzing the U.S. based off census data. Who knows what the census is? What the heck is census, and how do I have data because of it?
Oh, I know. I forget what it is.
Nothing? Nobody? When are you guys born?
Oregon.
03, 02, around there. So, every 10 years in America, a census is done. A census is just one big survey of everybody. But of course, they don't get responses from everybody, but they use the responses they get as a sample to populate some data. So, our census data then gets put together, and this shows you demographics. So based off ages, so you've got little charts down here that tell you what it's referencing, and I'll try to hang up a couple nice versions of this. And then you've got populations, so depending on the state color, depends on their population. You've got on here median age, you've got average family size, you've got population density. So if you look up here, this is pretty interesting. So population density, out here in Pennsylvania, more than 90 is the density in those like red parts. Ohio falls into like the 46 to 90 range. But as you come west, what happens to the population?
They're bigger states.
Well, the density becomes less. Why?
They're bigger states.
They're bigger states. How did we settle the United States?
Oh, well.
We made colonies on the
Where did we start? The east, and we worked our way west, so less people ended up out west, less families ended up out here. So still, when you look at population data, that shows. This was done in the year 2000. I do not have maps for the 2010 census data. Now that I think about it, I should try to get some. But if you are interested in this, I might try to put these up on the back wall here. Mr. Allen gave me these. And I think I still have a couple nicer copies stashed away somewhere. But pretty interesting to compare the states to one another. So when we're asking, do more people live in Maine or Hawaii? Are we going to look at one population or multiple? And if it's multiple, I want to know how many is it? Zach, what do you think? Maine versus Hawaii? Yeah, we're going to need 2 different populations there, because we're comparing the Maine population to the Hawaii population. there are actually, fun fact, there are more people in Franklin County, like Columbus's county that we live in, than in the entire state of Maine. A whole state versus one county. That's why our population density, we have people like stacked on top of each other downtown. States like Maine, very, very spread out. Nobody, like, there's no high-rise apartment buildings or anything like that. Is the median number of people per residence greater in Chicago, Los Angeles, or Philadelphia? Luke, what do you think? How many populations did we look at there? 3, because we've got Chicago, LA, and Philly. Bella, what is the age of the oldest U.S. citizen? Yeah, because we're looking at the entire U.S. altogether. I don't want to split it up because I want to know the oldest person out of everybody. And what percent of each state's population is male? Katie, how many populations would we be looking at there? Yeah, but how many populations does that give me then? Because we have 50 states, that would give me 50 different populations that I would have to look at, which is what they've done on those census maps, is break up the states individually, or for some of the things, they look at the U.S. as one big whole data chunk. All right, flip to the back. Same questions here. What? All right, thank you, Copy Center. Did this happen with all? Don't tell me this happened with all of them. Yeah, we're just gonna do our own. Okay, the other ones are okay. All right then. Well, womp womp. All right, let's just do this together. It's okay. We can just do this together. I'm trying. If we get through this quick enough, we can get out Chromebooks and start your homework. Anyone that still has any?
Oh yeah,
What?
I didn't see it.
Yeah. So, we can probably skip these. I think you guys got this pretty well now. So the main thing here, before we move on and let you guys start homework, is that we can then take our data that we collect and make inferences based off that. What is an inference? You guys talked about this in language arts. I heard you talking about this. Eli? It's not just a guess.
It's an educated guess.
Cassidy?
It's an educated guess.
So, yeah, I still... Okay, so how is it educated?
So,
You can't just say my guess is educated because I am educated.
okay, so it's like a guess that you do based off of like different information.
Yes, I could not even say it better than myself. An inference is a guess or a prediction that you make based off data that you have collected. So I would actually like you, I'm sorry, to write out that an inference is a judgment from interpreting a set of data. An inference is a judgment based off interpreting data. A judgment, a prediction, a guess. You can say whatever you want. Judgment, they just use as like prediction, guess, whatever. So when I look at population A here, it says based on sample A, 65% of population A loves to sing. They've got a sample. Based off their sample, they're inferring that the population will match. This is like what we did last chapter when we did predictions, like estimations of how, the sample versus the population. In sample B, 30% of people love to sing, so they figure that in population B, 30% of people will love to sing. Now a comparative inference. Now, I mean, you should be able to remember this. A comparative inference is just an inference that compares two things. So if I know that 65% of sample A love to sing and 30% of sample B love to sing, then I could infer that greater percent of population A loves to sing than population B. So population A is more likely to love to sing than population B is because their percent was larger. That seems like a simple idea, but some people still have issues with it. It's based off the data that you see. You can make an inference. You don't know that it's true, but we're assuming if the data is true, then my inference should be true. Hello. There we go. All right, so real quick, then we'll give you about 10 minutes to work on your homework probably. If we look at these fish, make a conjecture. A conjecture is just an educated prediction. Make a conjecture about why there are two peaks in the dot plots of both samples. So we are comparing pond A to pond B. We have a graph of pond A here, a dot plot. Why do you think there's two different peaks? Luke?
Because that's like the most amount of lengths on fish.
Okay. So they're koi fish. We see that they're koi fish from two koi ponds. Brianna?
Could those be either, could those be larger ponds?
Sure. Anything else? What if this is the main length of like a young koi fish? And there's, they probably had a bunch of babies last year, and now we've got these young fish swimming around. And this is the main or standard length of an adult fish. We can make different inferences like that. Or we could say maybe there's two types of koi in there. There are many types of koi. And maybe this is the maximum length of one type of koi, and this is the max length of the other type of koi. Like any inference that you can make based off this. And then we could compare to pond B, and we could make some comparative inferences based off that. I'm just going to let you guys dive into your homework, and then from there we'll see if we have any questions. We can cover them together. So go ahead and grab a Chromebook. We've got actually about 15 minutes to work on your practice. I didn't want to do too much today because we're missing our orchestra friends.